Who invented the lightning rod?
Although a Russian tower built in 1725 had what would now be called a lightning rod, credit is usually given to American inventor Benjamin Franklin, 1706 to 1790. He invented the lightning rod in 1749 to protect houses and tall trees from being destroyed by lightning bolts.
What is a jelly donut, JD?
Informal energy unit. Energy in a medium-sized jelly-filled donut. 1 JD equals 239 kilocalories.
How do refrigerators and air conditioners work?
As you know, when a liquid evaporates into a gas, it is cooled. Heat flows into the system. The opposite process. The condensation of a gas into a liquid results in an increase in thermal energy and an output of heat. A refrigerator circulates a refrigerant, a liquid that evaporates at a low temperature. Through tubing, the gas is compressed by an electrically driven compressor. The pressure and temperature of the gas increases. Coils of the tubing outside the refrigerator cool the liquid and heat the air around them. As it cools, the refrigerant condenses back to a liquid that goes through a tiny hole, called the expansion valve. The pressure drops, evaporating the liquid, making the gas cold. The tubing containing the cold gas is in the inside of the refrigerator, making it cold, and cooling the food. An air conditioner works in a similar way. The evaporator is in the unit inside the house and the compressor is outside. Because of the work put into the compressor, heat is removed from the air inside the house and transferred to the outside air. The diagram below shows work and heat flows in a refrigerator or air conditioner. The first home refrigerators used ammonia as a refrigerant, but ammonia is toxic. In the 1930s, Freon was first developed by the DuPont Company of Wilmington, Delaware. Freon is a chlorofluorocarbon, CFC. If freon escapes, it carries chlorine atoms to the upper atmosphere. Their ultraviolet radiation from the sun separates one of the chlorine atoms from the CFC. That atom converts ozone back to oxygen, contributing to the destruction of the ozone layer, an essential barrier against harmful ultraviolet sunlight. Freon's destructive nature has been known since the 1970s, but it was not until the early 1990s that legislation was implemented banning the use of freon in new air conditioners and refrigerators. It has been estimated that in 2002 there was 6 million tons of freon in existing products. Unfortunately, when the chlorine destroys an ozone molecule, the chlorine is not destroyed, but instead continues to live for a while, destroying more ozone. In fact, more Freon is still headed toward the upper limits of the atmosphere. For it can take several years for Freon to reach such elevations. DuPont and other corporations have developed replacements for Freon that replace the chlorine atoms with hydrogen atoms. These substances do not harm the ozone layer and are in use in refrigerators, air conditioners, and aerosol cans.
How does gravity fit into the Standard Model?
It does not fit. Gravity, explained by Einstein's general theory of relativity, is extremely successful on the macroscopic scale. But, all attempts to create a quantum gravity have failed. So have attempts to fit gravity into the Standard Model.
What is a sparticle?
A supersymmetric partner particle. The sparticle for a boson is a fermion, the sparticle for a fermion is a boson. Including sleptons, squarks, gluonios, and photonios, sparticles are theoretical particles that are, or have been, proposed as part of an alternative to the Standard Model of subnuclear particles.
What is the sound barrier?
The sound barrier is the speed that an object must travel to exceed the speed of sound. The speed of sound is often used as a reference with which to measure the velocity of an aircraft. The speed of sound, 331 meters per second at 0 degrees Celsius, is Mach 1. Twice the speed of sound is Mach 2, 3 times the speed of sound is Mach 3, and so on.
What are the limitations on simple machines?
Simple machines must, like everything else, obey the law of conservation of energy. That means that the work done on the machine equals the work the machine does plus the heat the machine puts out because friction has increased its thermal energy. Some machines are highly efficient, meaning input and output work are almost the same, while others put out only a fraction of the work put in. The drawing on page 74 shows a simple machine where the machine has warmed up. That means its thermal energy has increased. It is now hotter than its surroundings, so it transmits heat to its surroundings, which are not shown on this diagram. The output work of the machine is smaller than the work put into it. That means that for the same input force, the output force is reduced by an inefficient machine.
Who was the first American to win the Nobel Prize in Physics?
In 1907, for the development of extremely precise measurements for the velocity of light and his work on optical instruments, German-born Albert A. Michelson, a naturalized U.S. citizen, won the Nobel Prize in Physics.
Are emission and absorption the only ways light interacts with an atom?
In 1917, Albert Einstein proposed a third way light could interact with an atom. If a photon with the correct energy struck an atom in the excited state, then the atom would be stimulated to emit an additional photon and drop to the lower energy level. The two photons leave with the same energy, in terms of a wave, same wavelength, and in phase.
What is general relativity?
Study of the descriptions and explanations of the causes and effects of gravity.
What is a magnetic field?
Just as the gravitational field is the region around a massive object that causes the attractive force on another object with mass. A magnetic field is the region around a magnet that causes forces on magnetic materials or other magnets.
What is a laser tweezer?
When a laser is sent through a microscope, it creates a tiny spot of very intense light in the material on the slide. A tiny plastic sphere will interact with the light in such a way that it is pulled into the center of the light. The light can be moved around the slide, dragging the sphere with it. That is the essence of a laser tweezer. The sphere can be chemically attached to the end of a long molecule, such as DNA. When the other end of the DNA is similarly fastened to the surface of the slide, the sphere can be used to stretch the DNA, straightening it out, and measuring properties such as the force needed to stretch it. Proteins, enzymes, and other polymers can be used in place of the DNA, and the forces they exert similarly measured. In addition, the tweezers can be used to sort cells, moving them to specific locations on the slide. We'll explore other mysterious consequences of quantum mechanics in the last chapter. Unanswered questions.
Who predicted electromagnetic waves?
In 1861, James Clerk Maxwell, 1831 to 1879, demonstrated the mathematical relationship between oscillating electric and magnetic fields. In his treatise on electricity and magnetism, written in 1873, Maxwell described the nature of electric and magnetic fields using four differential equations, known to physicists today as Maxwell's equations. Putting the four equations together predicted the existence of the electromagnetic wave. Maxwell was a professor at Cambridge University in England from 1871 until his death in 1879. He published other works on thermodynamics and the motion of matter as well. He also developed the kinetic theory of gases, and performed research in the field of color vision. Although Maxwell is not widely known to the lay audience, he is revered in the scientific community and rates in the pantheon of physics greats with Newton and Einstein.
How is radioactive decay used to determine dates?
Radioactive carbon-14, 14C, has a half-life of 5,730 years. It is produced in the atmosphere when cosmic ray neutrons strike nitrogen atoms. The 14C then reacts with oxygen to form carbon dioxide in the atmosphere and dissolves into the oceans. Plants take up the atmospheric CO2 in respiration and animals ingest it. Therefore all living things exchange both 12 CO2 and radioactive 14 CO2 throughout their lives. When they die, the exchange stops and the fraction of 14C to 12C in their bodies is fixed. As time goes on, the amount of 14C decreases. Objects up to 50,000 years old can be dated by radioactive carbon as long as correction figures agreed to by international agencies are applied. Willard F. Libby, 1908 to 1980, an American chemist, won the Nobel Prize in Chemistry in 1960 for his development of carbon-14 dating in 1949. There are several other dating techniques that use the half-lives of radioactive isotopes in rocks, including uranium/thorium and rubidium/strontium ratios that extend dating techniques to hundreds of millions of years. Radioactive uranium-235 decays into lead, Pb-207, very gradually. The half-life is 704 million years.
Do all elements have a fixed number of protons and neutrons?
The number of protons in the nucleus of an atom determines what element it is. So the number of protons is fixed. But, the number of neutrons can vary. Nuclei with the same number of protons but different numbers of neutrons are called isotopes. For example, carbon, with 6 protons, can have 5, 6, 7, or 8 neutrons. The isotopes are labeled carbon-11, carbon-12, carbon-13, and carbon-14. A more compact notation is 11C, 12C, 13C, and 14C. Chemical properties in general do not depend on the isotope. There are at least 3,100 isotopes of all the elements presently known.
What is the potential difference?
Difference in electric potential or energy difference divided by charge, also called voltage.
What is impedance?
Opposition to wave motion exerted by a medium.
Why are we static when sitting in a chair?
As long as you are sitting in a chair and not moving, relative to Earth, you are static. That means that the chair is supporting you with an upward force that is equal to your weight. You would remain static until some external force was exerted on you to start you in motion.
How do the speed and position of a dropped object vary with time?
As long as the only force is the gravitational force. Then the acceleration is the acceleration due to gravity, g. At Earth's surface the value is 9.8 meters per square second. In the English system g equals 32.2 feet/s2. If the object is dropped from rest at time t equals 0, then the velocity at a future time t is simply v equals gt. That is, the velocity increases by 9.8 m/s each second. If we measure the distance fallen from the position where it was dropped, then at time t it has fallen a distance d equals 1/2 gt2. The following table shows velocity and distance fallen for some selected times.
Who developed radar?
Radar was developed independently in many countries in the 1930s. But, in 1935, Robert Watson Watt, 1892 to 1973, a Scottish physicist, was the leader of a group that created the first radar defense system for the British military. Although a large number of nations, from the United States and Canada, to Britain, France, and Germany, to the Soviet Union and Japan, worked to develop radar systems during the 1930s. The British system of ground-based radar stations were the first to use radar effectively in warfare. By the early 1940s radar systems were miniaturized enough to be installed in aircraft so that they could engage other aircraft in fights at night. Ironically, Watson Watt became a deserving victim of his own technology 19 years later. According to Canadian police, Watson Watt had been speeding on a stretch of Canadian road and was detected by a police radar gun. Watson Watt willingly paid the fine and drove away.
What is the danger of short circuits in a home?
As described above, if there is only a tiny amount of resistance in a circuit, the current is very large and the wires get extremely hot. If, For example, the insulation on the wires in an appliance fails and the wires touch each other. The resistance drops and current rises. The wires, including those in the walls, can get hot enough to cause a fire. Household circuits are protected by fuses or circuit breakers. They are designed to open when current exceeds a predetermined limit. With the circuit now open, current stops and the wires will cool.
What is the evidence that neutrinos have mass?
The number of neutrinos detected from the Sun is only a fraction of what should be detected if our understanding of the nuclear reactions in the Sun is correct. A proposed solution to this problem is that neutrinos change from one flavor to another on their travel from the Sun to Earth. This phenomenon is called neutrino oscillation. It can only occur if the neutrinos have a small mass. Most experiments that support neutrino oscillation measure the lack of neutrinos of one flavor that they interpret as an oscillation into an undetected flavor. Recently an experiment has detected tau neutrinos in a muon neutrino beam from an accelerator at CERN and a detector 732 kilometers away, in the Gran Sasso tunnel in Italy. This flavor change supports neutrino oscillation.
Who discovered what makes an object hot?
Benjamin Thompson, Count Rumford, 1753 to 1814, who was born in the Massachusetts Bay Colony, but did most of his scientific work in the Kingdom of Bavaria, now part of Germany, deserves most of the credit. Before his experiments, most scientists thought that hot objects contained an invisible fluid called caloric. Experiments done before Rumford showed that when you heated an object it didn't gain weight. So caloric must be weightless as well as invisible. This result made many scientists suspicious of the caloric explanation, or theory. In 1789 Rumford drilled holes in bronze cannons through which a cannonball would be shot. He found that both the cannon and the metal chips that resulted from the drilling became hot. He determined the amount of water that could be raised to the boiling point by both the cannon bodies and the chips and showed that the caloric theory did not agree with his results. He finally concluded that in hot objects the particles that made up the material moved faster than they moved in cold objects. Using our present terminology, they had more kinetic energy. In their motion they vibrate back and forth, they do not move together like a thrown ball.
What are composite materials?
As was mentioned above, brittle materials like concrete have larger compressive strength than tensile strength. For that reason reinforcing bars, rebars, made of steel are embedded in concrete. The steel supports the concrete when it is under tension, reducing its tendency to crack and thus keeping it from failing. Composite materials have been used since ancient times when straw was added to clay to make bricks. The most recent composite materials use carbon fibers, less than 0.01 mm in diameter, that are light in weight. They're made of pure carbon, with very high tensile strength but low compressive strength. They are added to plastics to make them more rigid, increase their Young's modulus, without adding weight. Golf club shafts are often made of a plastic filled with carbon fibers, giving the shaft great strength with low weight. By varying the amount of carbon fibers, the flexibility of the shaft can be changed. Although it isn't really a composite, glass can be made to be less brittle. The key idea is to keep the surface under compression at all times so it won't crack. Glass sheets are made from the fluid state by cooling. If the surfaces are cooled quickly with strong blasts of air, it produces a form of glass called case hardened that was used for shatterproof lenses in eyeglasses. In the 1970s, a chemical method was invented that could be used on cold glass. It involves putting the glass into a bath of potassium salts. The potassium replaces sodium in the surface layers of the glass. The larger potassium atoms expand the surface layers so that the interior portion of the glass compresses the surface, keeping it from developing cracks.
What is temperature?
A quantitative measure of hotness. The more thermal energy an object has, the higher its temperature.
How much charge is inside the sphere of a Van de Graaff generator?
Zero. When negative charges leave the rubber belt, they move immediately to the outer surface of the sphere. Negative charges like to be as far away from each other as possible. So they move to the outer surface of the Van de Graaff generator's sphere. An old, damaged photograph of British physicist Michael Faraday, who was the first to describe an electric force in terms of a field. He also invented the Faraday cage, which permits electric charges on the outer shell but not within the cage itself.
What is a torr?
Measure of pressure using measurement of height of mercury in a glass tube that would create a pressure that balances the pressure of the fluid. Used to be called millimeters of mercury, mmHg.
When was magnetism discovered?
the discovery of rocks that attracted certain metals is lost to history. As was the case with electrostatics, Aristotle, 384 to 322 BCE, credited Thales of Miletus, 625 to 545 BCE. With the first scientific discussion of the attractive power of the rock later called lodestone. The word magnet comes from the region of Greece where lodestone is found. But the power of lodestone was found by other people around the same time. At the time of Thales' life, an Indian surgeon, Sushreta, used magnets to aid surgery. In the 4th century BCE, the Chinese Book of the Devil Valley Master says lodestone makes iron come. In the 11th century CE, the Chinese scientist Shen Kuo wrote about the use of a magnetized needle as a compass in navigation. By the next century, the Chinese were known to use a lodestone as a shipboard compass. 100 years later, the British theologian, Alexander Neckham, described the compass and how it could be used to aid navigation. Some people thought that the pole star attracted the compass, while others thought that the source was a magnetic island near the North Pole. In 1269, the Frenchman Petrus Peregrinus wrote a detailed paper on the properties of magnets. But the most comprehensive and famous work was written by William Gilbert in 1600. Gilbert concluded that Earth was a giant magnet.
What are low-frequency, LF, waves?
Frequency 30 kHz 300 kHz.
Can the size of umbras and penumbras change?
An umbra and penumbra exist wherever there are shadows produced by a large light source. When an opaque object casts a shadow on a surface close to it, the shadow will be clear and distinct. Because it has a large umbra section and small penumbra. If, however, the object casting the shadow is closer to the light source, there will be regions on the surface where light from some of the source is not blocked by the object, producing a smaller umbra and a larger penumbra. A lunar eclipse occurs when the Earth is directly between the Moon and the Sun.
If white is the combination of the colors of the rainbow, what is black?
Black, the exact opposite of white light, is the absence of light or the absorption of all light. It may seem obvious to us, but Newton was the first to recognize this fact. A black piece of paper appears black because all the light is being absorbed in the paper. None is reflected back out to our eyes.
What is an inclined plane?
A ramp is an example of an inclined plane. Instead of lifting an object to the height at the end of the ramp, You move it a much longer distance on the surface of the ramp, but it requires much less force. So, the ramp has a larger output force than an input force. It has a mechanical advantage greater than 1. That is, ma equals foutput slash finput equals, length of ramp, slash, height of ramp. According to the Americans with Disabilities Act, a wheelchair ramp should have a maximum increase in height of 1 for every 12 length of the ramp. The Act says that the maximum rise should be 2-1/2, so the ramp must be 30 long. The input work is finput xl, where L is the length of the ramp. The output work is foutput xd, where d is the rise and foutput is the weight of the person plus wheelchair. If there is no sliding or rolling friction, then finput xl equals foutput xd. The mechanical advantage is L/d. So finput equals foutput slash ma, and the force needed to push a wheelchair up the ramp is given by finput equals foutput slash L/d. If the weight of the person plus the wheelchair is 200 pounds, then the force needed to push the person up the ramp is finput equals 200 pounds slash 3072.5 equals 17 pounds. Look at the cutting edge of a scissors. It's an inclined plane where the input is the force and motion of the closing blades and the output is the outward movement of the paper after it is cut.
What are other examples of the conservation of momentum?
If there is only one object in the system, then with no external forces, Newton's second law says that its velocity will not change. Conservation of momentum also says that its momentum won't change. If the momentum was 0, it will remain 0. If you shoot a rifle or shotgun, you are often told to hold the gun tightly against your shoulder. What's the physics explanation for this admonition? When the gun is fired, the bullet's momentum changes. Its new momentum is in the forward direction. So, according to the law of conservation of momentum, the gun must gain momentum in the opposite direction. It will recoil. If the gun isn't held tightly to your shoulder, its mass is relatively small, and so its recoil velocity will be large. When it hits your shoulder, it could cause injury. If, on the other hand, the rifle is tight against your shoulder, then the mass is the mass of the rifle and your body. The recoil velocity will be much smaller. Momentum backward. With no external forces on the rocket gas system, the rocket's momentum must increase in the forward direction. It will speed up. When the rocket is on the launch pad, there is an external force on it, the force of gravity.
What causes the tides?
The moon's gravitational field exerts a force on the water. Because the field and force depend on distance, The force on the water closest to the moon is strongest. The force on Earth is weaker. And the force on the water on the far side of Earth is smallest. So the water nearest the moon is pulled toward it. And Earth is pulled toward the moon more strongly than the water farthest from the moon. For that reason there is a tidal bulge in the water near the moon, and another on the far side. The bulges, which are the high tides, are not directly under the moon because Earth's rotation drags the water along with it. Because the day is shorter than the lunar month. The high tides actually come about 2 hours before the moon is overhead. Tides also vary greatly with location. The largest tidal variations occur in the Bay of Fundy between the Canadian provinces of Nova Scotia and New Brunswick, where the largest recorded range was 17 meters, or almost 56 feet. There have been many proposals to put a dam across the bay and use the tides to generate electricity. But environmental concerns have blocked construction in that bay. The sun also affects the tides, but much less than the moon. When the sun, Earth, and the moon are aligned, which happens at both full and new moons, the tides are especially high.
What happens to the helium balloon that a child releases?
If the balloon is tied tightly, the balloon will expand as its altitude increases. This expansion is caused by the lower atmospheric pressure at higher altitudes. Eventually, the helium's volume increases so much that the rubber balloon breaks, releasing the helium.
Do the masses of the quarks add up to the mass of the proton?
The mass of 2 up quarks and 1 down quark sum to 8.81 MeV/C2, and gluons are massless. But the proton's mass is 938 MeV/C2. How can that be? The remainder of the mass is due to the high energies of the quarks and gluons within the proton.
What is the name of the supporting force from the chair?
Another term for a supporting force is normal force. The normal force is always directed perpendicularly out of the surface. The normal force of a chair is straight up if the chair is on a level surface, while the normal force of an incline would be perpendicular to the surface of the incline, and not perfectly vertical. The term normal was derived from the geometrical name for a 90 degrees angle and is not the opposite of abnormal.
What elements beyond uranium have been discovered?
Elements 113 to 118 have temporary names until the International Union of Pure and Applied Chemistry decides on the name. The number of atoms detected in the decays of elements 113 to 118 vary between a dozen down to even one. In the search for element 117, a total of 1019 Ca ions bombarded the Californium target and resulted in 3 atoms of element 117. Elements up through Californium 98 have been produced in milligram or gram quantities. They have been used as target materials for the accelerators that bombard them with ions in the search for heavier elements. The estimated cost of producing enough Einsteinium, 99, to be used as a target is $50 million.
What is the origin of the masses of the quarks and leptons?
Peter Higgs, 1929, a British physicist, proposed a mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z. The mechanism successfully predicted the mass of the Z boson. But it requires the existence of a particle, called the Higgs boson. Despite many searches, the Higgs boson has not yet been discovered. Physicists hope that the Large Hadron Collider, LHC, that started operation in 2010 will accelerate protons to high enough energies that the Higgs will be found.
What is power, P?
The change in energy divided by the time taken.
What is a Fourier theorem?
Any repetitive waveform can be constructed from a series of waves of specific frequencies, of fundamental and higher harmonics.
What is the newest hybrid of bridges?
One of the newest, prettiest, and most economical bridges is the cable-stayed suspension bridge. With its sleek lines and thin roadways, it is the perfect bridge for most mid-span designs. The Tatara Bridge, in Onamaiki, Japan, completed in 1999, is the longest cable-stayed bridge in the world, with a span of 890 meters, 2,919 feet. Cable-stayed bridges suspend the roadbed by attaching multiple cables directly to the deck supporting the roadbed. These cables are then passed through a set of tall vertical towers and attached to abutments on the ground. Such engineering methods reduce the need for heavy, expensive steel and the massive anchorages that are needed to support suspension bridges.
Why do you need two connections at the ground potential?
Because when the appliance plugged in draws current, there is current through both the black and white wires. Each wire has resistance, so there will be a voltage drop across the white wire. And it will be above ground potential at the outlet. While this voltage will be small, it could be dangerous. The green wire, which carries no current, will remain at ground. It can be connected to the metal case of the appliance, assuring that the case will remain at ground potential. When installing an electrical outlet, note that the green wire. Okay, you can't tell in this black and white photo, but it is there. Is the grounding wire, which must be attached to the grounding contact on the outlet.
What is a series circuit?
A series circuit consists of electrical devices such as resistors, batteries, and switches arranged in a single line. There is only one path for the charges to flow through. And if there is a break anywhere in the circuit, the current will drop to zero.
What are maglev trains?
Maglev, or magnetically levitated trains, are different from conventional trains in that they use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks. Some demonstration trains have reached speeds of 500 km per hour, 300 miles per hour. Although the United States has no maglev train, nor an active research program in this technology, Germany and Japan have conducted a great deal of research in the field.
How is an electromagnetic wave created and detected?
Electromagnetic waves are created by accelerating electrons that create an oscillating electric field. This field in turn creates an oscillating magnetic field, which creates another oscillating electric field, and so on. The energy carried by the waves radiates into the area around the moving charges. When it strikes a material whose electrons can move freely, it causes these particles to oscillate.
What is nuclear fission?
Radioactive nuclei can decay in another way: they can split in two. This process is called spontaneous fission. Fission can also be produced artificially by bombarding nuclei with low-energy neutrons. In fact, fission was discovered in this manner.
What is electrostatics?
Electrostatics is the study of the causes of the attractive and repulsive forces. that result when objects made of two different materials are rubbed together. Electrostatics is the study of what is often called static electricity.
Speed of light in a vacuum, c.
299,792,458 kilometers per second.
What does energy efficiency mean?
In most cases, thermal energy is not a useful form of energy for a system. You want the energy content in the gasoline in your auto to give it kinetic energy, not to make it hotter. The cooling system uses a water antifreeze mixture to cool the engine and warm the radiator. Where air flowing through it is heated, thus cooling the fluid. The thermal energy in the heated air is often called rejected or waste energy. An auto is about 20% efficient. That is, only 1/5 of the energy in the gasoline is converted into the kinetic energy of the auto. In addition to the hot air from the engine, tires get warm from flexing. And the brakes get hot when they are applied. All this thermal energy is rejected or waste energy. Your home furnace converts the chemical energy in oil or gas or electrical energy into thermal energy, either of air or water, depending on whether you have forced air heat or hot water radiators. But not all the energy goes into heating the house. Some leaves through the chimney as rejected or waste energy. Heating systems used to be about 60% efficient. Newer systems can be as much as 95% efficient. Means of increasing the efficiency of auto and home appliances is an active area of research as nations try to conserve as much of the produced energy as they can. Your body also uses only a fraction, again about 20%, of the food energy to move your limbs when you walk or run. Your body is cooled by contact with the air, or by evaporating liquid, either perspiration or the humid air expelled by your lungs.
Who is Roy G? BIV?
The colors of the visible light spectrum, in order from long wavelength to short, can be remembered using the fictitious name Roy G. BIV, which is an acronym for red, orange, yellow, green, blue, indigo, and violet. Each individual color has a particular wavelength. And as the wavelength changes, the color changes to the next color on the spectrum. When combined with the appropriate intensities, these colors form white light.
What is a light interference?
Light waves from two closely spaced slits or two surfaces of A thin film that produces regions of bright and dark regions.
What is nearsightedness?
Also called myopia. Allows only objects relatively near the eye to be focused on retina. Images from distant objects are in front of the retina, so they are blurry.
What is Bernoulli's principle?
In 1738, a Swiss physicist and mathematician named Daniel Bernoulli, 1700 to 1782, discovered that when the speed of a moving fluid increases, such as the wind blowing through the corridors of a city, the pressure of that fluid decreases. Bernoulli discovered this while measuring the pressure of water as it flowed through pipes of different diameters.
What is a specular reflection?
Light rays reflect into a single direction, as from a mirror.
What is the coefficient of friction?
Friction force divided by normal force.
Is light a wave or a particle?
Light, and other forms of electromagnetic radiation, has the properties of both a particle and a wave. As a wave, it is described by its wavelength, frequency, amplitude, and polarization. It has the ability to diffract and interfere. As a particle, it has energy, momentum, and angular momentum. It has the ability to be emitted and absorbed, and to scatter off other particles, transferring energy and momentum. In some experiments, it acts like a wave in part of the experiment and a particle in other parts. For example, if you put a beam of light through a pair of narrow, closely spaced slits, the so-called Young two-slit experiment, you get an interference pattern with alternating stripes of light, where the light through the two slits constructively interferes, and darkness where the interference is destructive. If you now greatly reduce the intensity of the light and use a detector that can detect individual photons, you will have regions where a large number of photons arrive and others where none arrive. The regions are exactly where the dark and light stripes were. If the intensity is so low that there is only one photon in the apparatus at a time, how can the dark and light regions be understood? Particles can't split, with half going through one slit, half through the other, so the two halves interfere. If you try to modify the experiment so you can tell through which slit the photon came, you destroy the interference pattern. Physicists have grappled with this mystery for decades. There are no easy explanations. Perhaps the fault lies with our language and thinking. We simply do not have the correct words or mental concepts to describe and understand how light works.
When tossed in the air, why do hammers wobble end over end?
In earlier chapters we considered only point objects. That is, an object so small that it could be thought of as the tiniest ball. Now we want to expand our considerations to large objects. First think of a baseball. If a baseball is tossed into the air, the ball follows a smooth parabolic path as described earlier in this book. If, however, a hammer is tossed, its path appears much more complex. Why? All objects are made of atoms. The mass of the object is the sum of the masses of all the atoms. And the force of gravity on each atom is proportional to the mass of that atom. In a baseball, the center may be made of different materials than the surface, but if you ignore the laces, the ball is made up of the same materials regardless what the direction is. That is, the ball is spherically symmetric. The center of gravity in any object is defined as the average location of its weight. Because the mass is distributed evenly throughout a baseball, the center of gravity is located in the center of the ball. However, for an object such as a hammer, with a metal head and a wooden handle, the center of gravity is not directly in the middle. Since more mass is located in the metal head of the hammer, the center of gravity is closer to that point. The laws of physics state that the center of gravity follows a parabolic curve when tossed in the air. Indeed, although the ball and the hammer do not appear to have similar motions, their centers of gravity do. If you watch closely both the center of a baseball and the center of gravity of a hammer, you will see that they both follow parabolic paths when thrown. Because the force of gravity is proportional to the mass, the center of mass is at the same location as the center of gravity.
What causes the flow of charges in a voltaic pile?
Volta invented the term electromotive force, EMF, to describe what causes the separation of charges. The more disks there were in the voltaic pile, the greater the EMF. Unfortunately, the word force is an incorrect use of that term. Because there is no mechanical push, measured in newtons, on the charge. The correct term is potential difference or voltage, the energy change per unit charge separated. Both the term voltage and the unit in which it is measured, the volt, V, are named after Volta.
How is the brightness of light measured?
There are two separate systems to measure the intensity of light. The first is a physical system that measures energy or power transferred. The second system measures the effect of light on the eye, in other words, how bright we see the light. You are familiar with the watt. It's the rate at which energy is transferred. The equivalent unit for light, the luminous power, is the lumen. If you look at the box a lamp comes in, you'll find both the electric power it dissipates in watts, W, and the luminous power in lumens, Lm. For example, a 25W clear bulb emits 200 Lm. A 100W lamp emits 1720 Lm. A 60W halogen lamp emits 1080 Lm. Compact fluorescent lamps produce more light for the same power. A 25W lamp is rated at 1600 Lm. Light travels at slower speeds through mediums denser than a vacuum, such as air or water or glass. Light travels at about 225,400 km per second through water versus 299,792 km per second in a vacuum. The intensity of light depends on the degree to which the lamp spreads or focuses the luminous power. If the light goes into all directions, it won't be as intense as it would be from a reflector spot lamp that reflects light to form a narrow beam. The unit in which light intensity is measured is the candela, CD. If a 100W, 1,720 Lm lamp could spread the light into all directions, it would have an intensity of 137 CD. But, if the same lamp were a spotlight, concentrating all the light into a 30 degrees angle, then the intensity would be about 640 CD. As the distance between the lamp and the surface illuminated increases, the illuminance provided by the lamp decreases according to the inverse square law. Suppose you have a light luminous power of 1000 Lm 1 meter, 3.2 feet, away from the surface. If you now move the lamp to 2 meters, 6.5 feet, away, the illuminance would be 1000 Lm divided by the distance squared, or V22. That is, V4 of the illumination at 1 meter. If you moved the lamp to 3 meters, 9.8 feet, away, the illuminance would decrease to 1/9 the original illuminance.
Where would you put the material to be cut if more force is needed to make the cut?
You would put it nearer the pivot. On the other hand, if the material is easily cut, cutting near the tip of the blades provides enough force and speeds up the cutting.
What is a superconductor?
Superconductors allow electrical current to travel without resistance, and therefore no voltage drop across them or energy loss within them. Superconductors must be cooled below their critical temperatures to have no electrical resistance. Some elements, compounds, and alloys that are superconductors are lead and niobium nitride, and a niobium titanium alloy. All these require liquid helium to cool them to their critical temperatures. In the 1980s, some ceramics were found to have much higher transition temperatures that could be reached using much cheaper liquid nitrogen. The first found was yttrium barium copper oxide. As of 2008, a family of materials including iron, such as lanthanum oxygen fluorine iron arsenide, was developed.
What challenges are there in building skyscrapers?
The first challenge is to design a foundation that can support the tremendous weight of a large building. The best way is to dig down to the bedrock. This can be as close as about 21 meters, 70 feet. In New York City to almost 61 meters, 200 feet, in Chicago. If the distance is short, holes can be bored and concrete piers can be formed in the holes. More frequently, a caisson is required. This is a large hollow waterproof structure that is sunk through the mud. Pulling it into and then out of the top of the caisson. A third method is go build a large steel and concrete underground pad that floats on the top of a hard clay layer. The load that the foundation must support includes the weight of the building, its furnishings and equipment, and the changing load of occupants. In addition to the loads, strong winds must also be considered. The walls of early tall buildings were constructed of masonry that supported the weight of the building. The 16-story 65.5 meter, 215-foot, high Monadnock building in Chicago, built from 1889 to 1891, required 1.8 meter, 6-foot, thick walls at the base. It was so heavy that it sank, requiring steps to be constructed between the sidewalk and the ground floor. The second half of the building used a steel frame on which masonry was attached, allowing much wider windows to be used. The steel frames can be bolted, riveted, or welded together. When the 59-story, 279-met 915-foot, tall Citigroup building was constructed in New York City from 1974 to 1977, the frame was bolted together. But later computer models showed that if hurricane-strength winds struck the building, it would be in danger of collapse. As a hurricane moved up the eastern seaboard in 1978, workers hurriedly welded plates over the bolted joints. Luckily, the hurricane moved out to sea, sparing New York. Another effect of winds on tall buildings is to make them sway back and forth. While a variety of braces can reduce the sway, they add weight to the building. Another method is now used. The Citigroup building has a 400-ton concrete damper at the top. The damper moves back and forth, opposing the wind-driven motion of the building and reducing sway. Dampers, both liquid and solid, are used in tall buildings. Towers, offshore oil drilling platforms, bridges, and skywalks. The 210-meter, 690-foot, Burj Al Arab Hotel in Dubai has 11 mass dampers. The dampers can also mitigate the effect of earthquakes. Transporting large numbers of people into and out of upper floors is a challenge too. Those who design the elevator systems, as was demonstrated in the collapse of the World Trade Center buildings on September 11, 2001, stairways can be used in emergency situations. But the simultaneous movement of occupants down and firefighters up the stairways caused severe problems. Another consideration is the safety of occupants in case of fire. Some buildings have entire floors designed to be especially fire-resistant, so that people could gather there and be safer than on other floors.